Alright, hi everyone, and welcome. Hope you are doing okay. I am still doing fine. Right now, we will cover end-to-end programming and we will see how we can. Let's go to the beautiful diagram that we had. We will see how to start with our problem and then use some algorithms if necessary, and then write a program for that in C++ and then run that on our operating system. All right, this is a simple um, C++ program that I wrote here. It has one function, print name, simply receives a name and then print that name on the screen. And then we have the prototype, function prototype here, and necessary libraries, and yeah, that's it. So here we had our problem. The problem was simply write a C++ program, write a program, computer program that will print a name. It receives a name from the user and then print that name. All right, this was our problem. Algorithm. We didn't need to use any algorithm. It was very simple. This problem that we had was no-brainer, like very simple. And for the programming part, I use C++. We already know the basic syntax of C++ because we passed 1620. And yeah, that's it. And so right now we have our C++ program, the .c file, simple program.cc. Computers don't understand C++ code. They only understand binary files, 0 and 1s. How can we convert this CPP program to a machine understandable language? By using compilers, and compiler that we will use is G++, and G++ has different variation on based on different operating systems, but for Linux it is called G++ and the version is 6.3 as far as I remember. And then once we have the binary file, by using the compiler. And you remember last video, we discussed that we have two different tools for running our program. We're using compilers and interpreters, and C++ is both we can run C++ with both interpreters and compilers, but for now we are only using compilers. And yeah, so if you don't have any compiler on your system, please install one and just simply Google G++ compiler for your operating system and install them. There is one way to expedite this process, which is using IDEs. I'm using VScode right now, and if you have a VScode, you can go to the extensions, and right now I have C++ extensions here, and yeah, this is how I install G++ compiler for my Windows system. All right, and if I right now check the version of G++ or its availability here in the terminal, G++ dash dash version, yeah, the G++ or MinGW version 6.3, and yeah, everything is fine. So right now we have our cpp.cc file, we have our compiler, and right now let's see how we can convert our .cc to the binary file. All right, this is the folder. I only have one .cc file, simple underline program.cc. Let's compile this program, and G++ dash val. Dash val means print all the warnings. If there's any bug in my code, if there's any warning, please print all of them. And if you have any error, you don't get any output file. It asks you to resolve those errors before giving you the final binary file. And then dash std cpp C++11. You remember in our pipeline we had programming part and we are using C++. C++ also has different versions like C++11, C++ 17, 2020, 2023. Yeah, C++ has different versions. So by this flag dash std equal C++11, I'm asking G++ compiler to use the 11th version of C++, and next thing dash O means give me the output file, the binary file, and the name of the program, simple. But one more thing, guys, you see the address is f 1 session underscore underline session 1, but we are not in that directory. We are in single file directory. All right, let's go to that directory by using cd command, cd the name of that folder, single file program, and then let's run the G++ and G++ dash O, which means give us the binary file, the output file, and the name of your output file, whatever you want to call your output file. I will say output file, and then the name of your program, simple program.cc. Once you run this command, you will have output file.exe. In Windows, when you run G++ command and with dash O, it gives you binary file with .exe extension, but in Linux you don't have any extension. This is a subtle difference between two different operating systems, Linux and Windows. All right, let's run this output file. Output file.exe by dot, and another difference is in Linux we have dot slash the name of the binary file, but in Windows we have dot backslash. Press enter your name, Reza. This is the and then when you press enter, you will have you call the print name function to print your name, Reza. What an achievement. This is exactly the behavior that we expected, because this is the C++ that we wrote. It has a main function, it receives an input from the user, a name, and then pass that input to print function, and print function print that name with two other statements. All right, this was how we can use G++ compiler to generate the output file, and then ask the operating system to run that binary file for us. All right, the operating system that I'm already using is Windows, and in order to run my CPP program and use these commands like cd is basically a Linux command. A Linux command is a command is a term that you use in your terminal in this this is called terminal. To ask your operating system to do something. For instance, cd means change directory. To go to a directory, for instance, cd single file program means go to the single file directory. Right now you see I was in session 1 folder, and then I used cd go to the single file program, and then it changed my directory to session 1 / single file program. And in order to run my C++ program and use this basic Linux commands, I had to install a bunch of extensions like C++ extensions and WSL, which is a subsystem, Windows subsystem for Linux. Windows subsystem for Linux is a module. It's a tool that give you some features, give you some ability to use Linux features. For instance, if you use Windows subsystem for Linux on your Windows system, you can use Linux commands like cd, like ls, or other commands on your machine. But the best thing is using a Linux environment. But many of you are using Windows and Mac, but don't worry, Google Colab has got you, and you can use Google Colab for getting access to a Windows machine, to a Linux machine. And this is Google Colab. I created a notebook here, and right now we can use this environment, this platform, for running our Linux commands. And let's check the version of Linux command here on Google Colab, but I don't remember the command, so I had to check that. Linux command for checking the version of Linux. lsb underline release dash a. lsb dash release dash a. Okay, this is the Linux version that Google Colab is using. It is using Ubuntu 20.04. And so you can easily use this platform environment for running your Linux commands and probably doing everything that we need in this course. I haven't checked that completely, but I'm sure that you can do anything on this Linux environment. Alright, the first Linux command that we need to use here is remove command. I need to remove all these default files that are on Google Colab. So I will use remove-fr, which is a flag, means forcefully remove, forcefully and recursively remove everything. A star means everything. So let me run this command. Look at here. We had simple underline data, but when we refresh this, you see everything is gone. Okay. And when we use ls, we have nothing. ls means list all the files and folders. And when we use pwd, ls, they are all Linux commands. Current directory. and our current directory is, we are in the content folder. This is the content folder. If I click, I will go to the root, but I don't want to go to the root for now. All right, so let's drag and drop our simple program file here. We uploaded simple program here. Let's one more time use ls. Yep, you see we have our simple program file here. Okay, and then G+, let's check the version of G++ on Google Colab. It is G++ Ubuntu 9.4. You see the version is totally different from the version that we had here, dash version. And the reason is we have different operating systems. So don't expect that your program compiled by G++ on Windows behave exactly the same on Linux. There are like 1% of the time you get different behavior, but yeah. And let's check. Now we can run the program with exactly the same command. G++ -o output file simple program .cc. All right, let's refresh that, and then we have output file. Remember I told you on Windows we get .exe extension, but on Linux we don't have any extension. Yeah, you see right now we are on Linux system, and we compiled the program. We got the output file, but there is no extension. So there was also one other difference. We use // for running output file binary files, but on Windows we use // enter your name, Reza, enter, and then you call the print function. This is exactly the behavior that we expected. All right, so guys, if you don't have any Linux system, don't worry. Google Colab has got you. You can use Google Colab system, or there is another way. Use the Linux systems that we have in our school, we have in our university. You can either go there in person or use those servers, those Linux systems remotely. For using them remotely, you can use SSH, and also you need VPN first. You need to go and get into the firewall of our network, and then you can use SSH to connect to any of those Linux systems that we have. But Google Colab is way more convenient than using SSH and VPN. That's pretty much it. I don't think there is anything left here to cover. Hope you enjoyed, and see you later.